Hello everyone, welcome back. In this lesson, I will show you how to create the Python packages and install in our local system. In order to install the Python package, first we need to create the Python package. And for that, we have to follow these steps from step 1 to step 8. I have already done these steps and installed a package called math_package, which is in the directory called main_directory. After following these steps while installing the package, at step 7, when we run this command python setup.py and in the wheel file, a necessary applications will be generated like build, dist, and then math package import. But I will show you all these steps one by one. Let us begin with the step 1. Before we install a package, we need to check the Python version and the corresponding pip version using these commands python space hyphen version or capital V, and also the pip version python space hyphen m space pip space hyphen version. Let us open the command prompt. As an administrator, and then use the commands python __ version or capital. So here we can see the Python version and also the Python pip version. Sorry, it is pip only. So here we can see the latest pip installed in our system. Step 1 has been completed. Step 2 is create a Python package. In order to create a Python package, we need to create an __init__ Python script file inside the directory or folder where we need to create the package. For example, I want to make this arithmetic directory as a package which is inside the main folder or main directory. Since I have already used the main underscore directory and math underscore package to create a package, and I have already installed in my system. So for that reason, I have created a new folder called main underscore folder, and inside that I have copied and pasted this math underscore package and renamed with the name arithmetic. If you open this math underscore package, you will see the files what we have seen in the previous lesson. The same files can be seen in this arithmetic also with the underscore underscore init underscore underscore python script file. Step 2 has been completed now, because once you create the underscore underscore init underscore underscore python script file inside any folder or directory, that folder or directory will become a Python package. So we have successfully created a Python package. Now the remaining steps will help us to install and check the package we have created. So let us create a license for our package. In order to create a license, we need to follow some rules provided by the open source initiative. So here I have mentioned the URL where you can find the MIT license. So here is the MIT license and the sample license description. We need to replace the year and also the copyright holder with our name. In your case, your name. I have used this sample license text to create a license file. So here you can see the license file with the sample text with the year and the author name. In my case, my name. Next, the fourth step is we need to create a setup file. Here I have created a setup file. Inside the setup file, we have to use the setup tools to make our Python package as an installable package. So here we can see the code which is used to make our Python package as an installable package, because the name itself indicates setup tool means make the current Python package as an executable file. Setup indicates make the current file as an executable file. So this setup file will make this package as an executable file, but inside this setup file we have to mention this package name. So this setup file will have several arguments such as name, version, description, URL, author, author underscore email means the author email, license, package, details, classifiers, and zip underscore say. Name means the name of the package, version. For the sake of illustration, I have given this version 0.2. Let us change this version as 0.0.1, and then description testing math underscore package for global installation URL. Right now I am not going to deploy this package in PP organization, where we can host the open source Python packages created by the individual users. Next we have author. I have mentioned my name and email, one dummy email, and license MIT, and packages with this function, that is find underscore packages, which is inside the setup tools. And then classifiers, here we are mentioning the programming language, license type, and operating system, etc. And zip underscore save is equal to false, means how to make the executable file, whether a zip compressed or not. So this is how we can develop the setup file. So this is a Python file. So inside this setup.python file, we have to create this code by importing setup and find underscore packages from the setup tools package. Many authors use several other arguments and parameters inside this setup tool, but in order to install a small size package or a simple package in our local system, this type of setup file is enough. So that's why I have created the setup file with this code structure. Let us change the package name from math underscore package to arithmetic, because now we are using this arithmetic package instead of math underscore package, which has already installed in our local system. After creating the setup file, next step is to test the package in the interactive shell, means in the Python interpreter, and where the parent directory is present. For example, the parent directory in our case is main folder. Let us copy this folder, the directory, and then open the command prompt. Now change it to that directory using the cd command. Now we are in the parent directory where the package is present. Let us run the command python space -i space underscore underscore init underscore underscore dot py. Says cannot open file. Let us move to the parent directory exactly, that is arithmetic where the underscore underscore init underscore underscore dot file is present. So here Now let us run this code. Python space hyphen I space underscore underscore init underscore underscore dot py. So now we have successfully entered into the interactive shell. Now we can directly access all these functions which are inside the modules. We got 6, and for subtraction so we got 4, and similarly we can execute the multiplication and power functions which are inside the module multiplication underscore power module. Notice here I have not imported the package. This is because I am already inside this arithmetic package with this command python space hyphen I space underscore underscore init underscore underscore dot py. Let us come out from this interactive shell and go back to the main directory where our package is present. We have successfully checked our Python package arithmetic in the interactive shell and it works fine without having to import the package. Successfully checked the created package. Now the step 6 is we need to install some specific applications to install the Python package in our local system, like setup tools which is already present, but we need to check wheel, twine and tqdm files. So don't worry about these files, just follow the steps. Let us check whether these files exist in our system or not using the command pip space list. This pip space list shows all the available packages which are necessary to install any Python package or create any Python package, and also to do some specific operations. Setup tools which is present here with the version 67.1.0 and wheel which is also present here with the version 0.38.4, Wine, which is also present here with the version 4.0.2, and TQDM, which is also present above this Wine 4.64.1. If you do not find these applications or tools, you can use this command to install all these tools, like pip install and then the tools name separated by space, setup tools space wheel space Wine space TQDM. In my case, I have all these tools, so I no need to run this command. So I will not run this command and I will move to the step 7. In step 7, we need to create a wheel file, which is actually the installable file generated by the setup file. The actual installable application means the wheel file, which is generated by the setup.py Python script file, because inside this setup.py Python script file we have a code which will generate the wheel file. Let us enter into the where the package is present and run this command, because in this parent directory only we have the setup file. Hit enter after entering the command. So we have successfully created the wheel file. Here you can see the folders what I have shown at the beginning, that is dist and then arithmetic egg hyphen info. Now the actual wheel file to install the package is inside this dist folder. So here we can see the wheel file. So this is the file which contains all the information which is necessary to install a Python package. So let us use this command to install this wheel file. That is install space and then the wheel name. Let us copy this wheel name, click on it and then slightly click on the file name. It will copy it and then in the command prompt type pip install and then the wheel name. But this wheel is present in the dist folder, so enter dist / and then the wheel name. So we have successfully installed the arithmetic package in our local system. Now you can use this arithmetic package anywhere in our system. In order to check this, let us enter into the C drive where we were at the beginning stage. Now run Python and try to import the package arithmetic. So we have successfully imported the arithmetic package without any error. Let us import the modules addition, subtraction and multiplication power modules using the command prompt and then the package name, that is arithmetic import addition, comma subtraction, comma mul underscore power. We have successfully imported the modules addition, subtraction, multiplication underscore power. Now let us do some work. From addition, let us use the add function. Because addition is the module, inside this module we have an addition function with the name add, and inside subtraction we have sub, and inside multiplication and power we have multiplication and power functions. Let us add 5, 8, we got 13, and from subtraction dot sub let us subtract 20, 7. So we got 13. Now mul underscore power dot mul, which is the function. Let us multiply 4 by 7. We got 28. Inside this mul underscore power we have power function. Let us get the power of 7 to the power 4. We got to 2401. Alright, we have successfully created a Python package, tested it with the interactive shell and installed with the help of the setup file. In this lesson, I would like to tell you about few things where you will find some error. Sometimes we may get error because of some common mistakes. The first common mistake is when we are installing the Python. As a beginner, we will also install the Anaconda package. So in my case, I have installed Anaconda for data analysis and data science purpose, and also the Python software from the Python Software Foundation website. And the mistake what we do here is, while selecting the pip, which is the very important tool to install any Python package, we will select one particular pip, but we don't know the pip for which it belongs to, whether it belongs to this Python software which is installed through the Python Software Foundation, or the Python which is present in the Anaconda distribution. Because in my case, this Anaconda, latest version of Anaconda, is having Python 3.9 version. Let us check with the Anaconda prompt. Open the Anaconda prompt and then type Python. Here you can see the version 3.9.16 and the pip which is using pip space list. So here you can see so many packages inside the Anaconda distribution. But in our Python 3.11 version, that is the Python which is installed through the Python Software Foundation, that is Python, look at here, Python 3.11.0, we have only these many packages. Anaconda distribution consists of lot of packages, but the original Python application has a limited number of packages. So this is one method to check which pip tool we are using. Okay, suppose if the command prompt lists all the packages, means a lot of packages, then you can easily guess that the pip I am using is from the Anaconda distribution. So here you can see in the Anaconda prompt the Python is listing so many packages including notebook, Jupyter notebook, Spider, etc. And also if you type the command import sys, it will not import the sys. Let us close this. Sorry, let us enter into the Python and then import sys. And now if we try to print the sys.path inside this Anaconda prompt, we will get the list of folders and directories where the Anaconda packages are to be installed. For example, in the DLLS, Anaconda library, Anaconda 3 and users / admin / app data roaming Python 3.9 site packages. This is very important. And in the Anaconda library, site packages which are inside the Anaconda library and site packages Win32, means this is the folder where the library is present, and the executable Python file in this location. On the other hand, if I type the same thing inside my command prompt, which is using the Python version 3.11.0, and here you can see the list of same directories. Here nowhere you will find the word Anaconda, because this is the command prompt where I am running the Python which has been installed from the Python Software Foundation 3.11.0, not from the Anaconda distribution. Now you came to know how to identify which pip tool I am using to install the Python packages or any other scientific packages to do a specific task, and also to install a Python packages in our local system. If you install Python package using the Anaconda pip tool, and if you try to import that package and modules inside the normal command prompt, means the system command prompt, then you will get package not found or module not found error. And if you install the same Python package inside this Python environment, which is installed through the Python software package foundation, means using the pip tool comes with the Python software foundation. And if you try to import the same package inside this Anaconda prompt, or using the Python which is coming with the Anaconda prompt, in our case Python 3.9.16, we will get Python package not found error or module not found error. So how to avoid these mistakes and run the Python package properly? In my case, I have used the pip tool, comes with the Python software foundation, from where I have installed the Python application. But in most of the cases, users will have a doubt, and also they will fail to set the path of the particular pip in the system environmental variables. So in order to avoid the confusions and this type of mistakes, while installing any special packages which are related to the Anaconda, use the command conda install and then the specific package name. For example, to install TensorFlow in the Anaconda prompt, I need to use the command conda install and then the specific package name. So use conda in case of Anaconda, and in the case of Python application, use the command pip install and then the package name. Okay, this is one trick. And the second trick is, in order to change the pip in our system, we need to change the pip executable directory or path in the system environmental variables. And for that, we need to do some work. Let us see what is it. First, click on the start and then select the Python application, shell, or any software which you have installed through the Python software foundation. For example, in my case, Python 3.11 version. Right click and then click on more and then click on the open file location. Once again, right click and then click on open file location. So here you can see Python 3.11 version, which is installed through the Python software foundation website. Now inside the libraries, you can see some of the files, and inside scripts you can see the pips, means the pip tools which are available in this Python 3.11 version. And inside the tools, scripts, and inside the library you will find the site packages. If you open these site packages, you will see the installed packages. So here we can see the math underscore package what I have installed, and also the arithmetic package here what I have installed just now in front of you. Let us open this. So here we can see the modules which are in our package arithmetic. The same modules can be found in this math underscore package also. This is inside the Python 3.11 version. Okay. Now let us close this, and now open start once again, and then now this time select Anaconda and then select Anaconda prompt, then click right click and then click on more, and then once again open file location. Once again select this, right click and then click on open file location. So this is the folder where Anaconda command prompt is present. Let us click on the Anaconda navigator and see where it is located. So here you can see the Anaconda navigator in Anaconda 3 folder. So here we can see library. Inside this library we can see many packages. And here you can see the site packages. Let us open this, and here we can see the installed package. I have installed the math underscore package in this site package also. So here you can see the installed package math underscore package using both the pip tools. The same modules in this package, that is math underscore package. Therefore, if I open the Anaconda command prompt and input math underscore package, then also I will get no error. And if I open the Python interpreter and import the math underscore package, then also I will not get any error. But I have installed this arithmetic package only in the site packages, which is a part of the Python application installed through the Python Software Foundation. So this is the Anaconda prompt. If I try to enter into it and import arithmetic, I will get an error, module not found error. On the other hand, if I move to my command prompt and if I run this Python, which is nothing but 3.11.0 version, and if I import arithmetic, I will get no error. So this is how you can cross check where the package has been installed. And the third trick is open the side packages of a particular application. For example, Python 3.11, and go back to the script files where it is present. So here the scripts, where you can see the executable pip version. So this is the folder, that is scripts, and this is the path, this is the complete path where the new pip tools are present for this particular application, that is Python 3.11. Now select this path if you want to run the pip which comes with the Python application downloaded from the Python Software Foundation. Then go to start and then type system environment and then select edit the system environment variable. Click on environment variables and then here select the path and then click on edit and then click on new and then paste the path you have selected. But I have already copy and pasted, so no need to enter once again. You can see here I have already entered. Suppose if this path is below other paths, then select this and click on move up until it comes first. This is because when we open the command prompt and if we type pip, then command prompt will look for this path from top to bottom. Which one it finds first, then it will execute that one. So move this to the first, means as the top path, and then click OK. And similarly in the system variables, select path once again and then click on edit. Once again here click on new and then copy paste the same path, and here you can see the Anaconda scripts as well, but I have moved it to last, means at the bottom place. I have kept the scripts folder or directory where the Python pip will be selected, which is installed through the Python Software Foundation. In your case, if it is in somewhere at the middle, then select it and click on move up until it comes first or second. So this is the third trick, how we can avoid installing any Python package in wrong directories or in the wrong site packages. Means the site packages which are inside the Python version installed through the Python Software Foundation, or the site packages which is inside the Anaconda distribution. So this is all about how to create a Python package, how to develop, how to make it as an executable file using the setup file, and how to install properly using the installing softwares like setup tools, wheel, Twine, and then TQDM tools. And finally, how to check where actually the Python package has been installed. So thanks for watching this lesson. I hope you will definitely create your own Python package and install in your local system. Keep up the good work. See you inside the next lesson.